I'll turn it back over to you.
Great. Thank you very much, Will. So I will go ahead and repeat the information about the start of this workshop. And Kathy, can you go ahead and record now?
Recording has started. Polling is open.
Thank you, Kathy. Welcome, everybody. Again, my name is David Hunter, and it is my pleasure to welcome you to the 7th Annual EPRI IEA Challenges in Energy Decarbonization Workshop. Normally, this would be an intimate gathering in Paris. Of course, this is not a normal year, and we are attending from all over the world. On the positive side, a lot more people are able to attend this year. We actually have some 500 registered government representatives from numerous countries, agencies, and jurisdictions, dozens of universities, electricity companies, NGOs, stakeholders all over the world, New York to California, Brazil to Canada, South Africa to Sweden, Japan to Australia, Middle East, Hawaii, Philippines, and Indonesia. Lots more people are continuing to join, and I think some people will be watching the webcast afterwards because it is currently in the middle of the night where they are. I think that the thing that makes this workshop really special is the ability to bring together so many people with so many experiences related to decarbonization. And what makes this a great workshop is all of you participating and sharing your views, sharing your questions, sharing your comments. So I would ask you, following up on what Will said, please use the chat function now. Please introduce yourself, your name, where you're coming from. Feel free to put in something about yourself, what country you're from. But please use the chat and please do introduce yourself. One of the things we hope to do today is learn from the successes and failures of folks all over the world who are working on decarbonization. So you've got a lot of great experiences, and please share those with us. As Will said, you can ask questions in the chat. You can also use the raise hand function to raise your hand for questions, and we will respond to those. And we will be actively monitoring the chat, and we're encouraging speakers to respond to your comments in the chat as well for those that they're unable to get to during the session itself. It is now my pleasure to, and sorry, that is my dog in the background, but it is now my pleasure to introduce EPRI's Vice President for External Relations and Communications, Katie Herreza. Katie, over to you.
Thank you, David, for that great introduction and for all you've done to prepare us for success in this workshop. Good day, everyone. I'm very pleased to welcome you to the 7th Annual EPRI IEA Challenges in Energy Decarbonization Workshop. All over the world, governments, energy companies, and numerous other stakeholders are struggling with the question of how to decarbonize their system while maintaining reliability and keeping consumer costs low. That is the challenge that has brought us together today. For the last 7 years, EPRI and the IEA have partnered on this workshop series to address that exact question. With more than 1,000 members in 40 countries and about 1,000 research staff, EPRI has unparalleled electricity expertise. The IEA, with its 30-member countries, 8 association countries, and thousands of expert stakeholders, has tremendous depth and diversity of energy expertise. Working together, EPRI, the IEA, and all of you have shared your experiences, visions, and lessons learned related to energy decarbonization. In doing so, you have turned this workshop into one of the premier global events focusing on the challenges of energy decarbonization. Today, and for many years to come, the power grid is undergoing dramatic change due to evolving customer demands, environmental goals, and technological advancements. Complexity is increasing with more distributed resources, two-way power flows, and variable renewable generation. Managing these distributed resources creates tremendous opportunities, not just for consumers, but also for researchers who seek to address challenges that arise from this transition. Let's consider, what do we need to know to create a clean energy future? How can we most effectively use distributed resources to decarbonize the grid? What are the benefits of distributed resource aggregation and balancing renewables? How do we achieve seamless integration of centralized and distributed resources? When it comes to enhancing reliability and resiliency, how will distributed resources in the central grid interact? And ultimately, what options do we have to meet the many demands placed on the energy system today, whether it's to meet new customer demands, accelerated environmental goals, or technology innovation? Stay tuned. For the next 3 days, we hope to answer all of these questions. I'd like to take a moment to thank our friends at the IEA for all of their work on this event and for their strong collaboration with EPRI. This is the 7th year we co-hosted this event with the IEA, and I'm pleased to see it has shaped up as another strong event. As of yesterday morning, we had more than 450 people registered, representing every continent except Antarctica, and far exceeding our previous registration records. I'd like to thank Kazuki Satomori and his team at the IEA who've been meticulous in putting this event together, particularly Alejandro Hernandez, Keith Everhart, and Enrique Gutierrez. I should also note that just last week, we wrapped up another successful EPRI IEA event. We worked with Mechel Worstifer and her team at the IEA to host the 20th annual EPRI IEA IETA GHG Emissions Trading Forum. It's hard to believe EPRI and the IEA, along with IETA, have co-hosted that event for 20 years. Speaking to Mechel, I'd also like to thank her for serving on EPRI's Advisory Council. It is now my pleasure to introduce the Director of the IEA's Office of Energy Markets and Security and our longtime partner on this event, Kazuki Satomori.
Thank you. Thank you for the very nice introduction. The welcome. It is a pleasure to welcome everybody to the 7th Joint EPRI IEA Expert Workshop on Challenges in Energy Decarbonization. This year, with a focus on the role of decentralized resources. First of all, I would like to thank EPRI for the continued cooperation on organizing this workshop series, and the very nice, kind remarks from Ms. Katie Jeriza to her. This year's focus on decentralization is an important step to tackle key issues on innovation, policy making, and reliability, which we need to address to ensure that the modern energy systems are at the heart of sustainable recovery plans globally. The importance of secure, sustainable, and affordable electricity supply has come to the fore in the course of this year. And at the IEA, we have been working tirelessly to provide timely and precise guidance through the Sustainable Recovery Plan, as well as this year's editions of the newly revamped the Energy Technology Perspective and also the World Energy Outlook report. The electricity sector alone accounts for more than 40% of the energy-related the emissions, and if we are to meet the goals of the International Agreement on Climate and Energy Access, the global share of renewable energy needs to rise from 10% to 50% and beyond by 2050. This implies increasing reliance on greater shares of distributed energy resources, including solar PV, wind, and battery storage. But a greater portfolio of options, such as the interconnectors, electric vehicles, and greater integration with heating and gas infrastructure. This technological shift in power systems toward the greater decentralization and digitalization calls for rethinking the way we manage security and flexibility, and for innovation in policymaking. Earlier today, we released the IEA's first ever report on electricity security with insights on energy transitions with higher share of variable renewables, cybersecurity, and climate adaptation. This is the first of a series of in-depth reports on this topic, which will certainly pick up many insights from the discussions that will take place over the coming 3 days. In the coming years, we will continue to work on digitalization and distributed energy resources with a greater emphasis in implementation and providing policymakers with the tools to evaluate pilots and scale up their experiences. I am confident that the discussion in the coming days bringing together the network companies, regulators, technology providers, and industry associations will provide the right foundations to strengthen this stream of work. So now, without much ado, I wish you an excellent discussions and would like to yield the floor to Deepika Barmi, the Director of External Relations and Communications at EPRI, to start the first session.
Thank you very much, Keisuke. And I'm going to interrupt for just 1 second to remind folks to note that the poll is open. So we do have questions up, and please answer those. You've got about 15 minutes left before we close the poll. Deepika, over to you. Let's see, Deepika, you are muted. We cannot hear you. No, now we can hear you. Perfect.
Thank you, David. Thank you, Keisuke. Thank you, Katie. Good morning. Good evening to our European colleagues. We're thrilled you've joined EPRI and IEA for a discussion on decarbonization and distributed energy resources to that end. The entire week of panels will examine where we are, where we want to be, and how to get there. But the first panel this morning will delve into that how. They'll look at how far we've come and what's in the works. You'll hear from someone in the federal government who knows policy, an EPRI scientist, an executive from the electricity distribution business in the UK, and a speaker who will explain how we'll pay for this new energy future, the financial piece. And don't forget to follow us on Twitter at EPRI News. So what I'll do is I'll introduce each speaker. Each will make a presentation. After all of the presentations, we'll jump into a lively Q&A. You don't want to miss that. So please share your questions via chat. Rudimentary questions are welcome because we have a broad audience. First, without further ado, David Nemso. David is the director of the Building Technologies Office at the U.S. Department of Energy. That office is housed in DOE's Office of Energy Efficiency and Renewable Energy. Now, he directs a $285 million budget for all sorts of technologies to improve efficiency and reduce emissions. David?
Thanks very much, Deepika, and thanks for having the U.S. Department of Energy. I want to also offer my appreciation to EPRI and the IEA for organizing this conference. And like others, I am willing to forgive you that we're not in Paris right now, since that's beyond any of our control. So I want to talk about the role of buildings. And when we think about the electric power grid, we should always think about buildings. After all, when Thomas Edison in 1882 started the first central station power plant in Manhattan, New York, commercial plant, he used it to power light bulbs, just a few hundred at the time, and it's expanded from there. But over the century plus since that happened, the power grid has tended to think of buildings as essential but passive consumers of electricity. End use, of course, but passive. And the grid would provide electrons, and they might be clean, they might be dirty, they might be expensive, they might be inexpensive, et cetera, and then buildings would consume them. I think it's time to change that, and that's why borrowing from Aldous Huxley, I think of this as the brave new world of energy efficiency and how buildings and energy efficiency and demand management can play an essential role in in the decarbonization of the power grid and the other things we're looking for. So let's go from there, and I'm looking forward to our discussion today. Somebody could click for me. First of all, these are U.S. numbers, so forgive me, all of you from outside the U.S., but the numbers are quite similar throughout the IEA world and the world in general. Buildings in the U.S. Consume 39% of U.S. energy consumption. I'm going from left to right here, and the dark green, it got cut off a little bit. The dark green bar is residential. The lighter green bar is our commercial buildings. In the U.S., we have 125 million buildings total. So that represents 39% of U.S. energy consumption. That's the largest sector, more than industry, more than transportation. 3/4, 74% of U.S. electricity consumption, and even more, it's hard to get quality data. If you look at that third bar, even more, 80% or more of peak power demand. Next is CO2, where buildings result in 35% of carbon dioxide emissions in the U.S. And cut off at the end there is a total bill in the U.S., a utility bill, that just means gas and electricity, not the other fuels, of over $400 billion U.S. per annum just to heat and cool and light and power our buildings. And of course, not only are those big numbers to show how big the stakes are here, but most of the building stock in the U.S., and it's even more in Europe and less in other countries, the building stock is over 20 years old. In the U.S., half of it is over 40 years old. In other words, that period in the 70s when the IEA was created and our modern energy period started. So many of these buildings last a long time, of course, and they are not built by modern standards. Pick your number on the bottom there. How much of that energy is wasted and not providing valuable services? It's at least 20%. If you want to argue 30 or 40%, I don't think anybody on this call will push back. So there's the challenge, there's the opportunity. Next, please. The most important thing I think to remember, of course, here is that for buildings, the buildings are busy doing something else. They're busy housing a family, or they're busy being an office or a hospital or a restaurant. They're not, we like to think of them as our energy resource, and they can be that, but primarily they're something else. So we always start at USDOE looking at what the occupant needs. If we can't keep the occupant happy and productive, comfortable, and healthy, then nothing else will matter. Luckily, we can do both simultaneously. So if you look at this graphic, we start with the occupant, that gentleman there sitting at his desk, and we think about all the ways we can control lighting and natural day lighting, air conditioning and other HVAC, and on top the algorithms to control that. And if we can do that, you see the little symbol of sensors there next to the lighting controls. If we can do that in a sophisticated way, we can take utility signals, and we can not only save energy, we can only promote energy efficiency through advanced lighting, advanced windows, efficient air conditioning, but we can do it in a way that's most responsive to the utility world, so that at times when that power is the most expensive, which is typically at times of peak when the system is stressed, we can turn up the savings and provide greater savings. And that's what we call demand flexibility. So it translates, I used to work in Australia, I know it translates differently in different countries, even within the Anglophone world, let alone other languages, but I'm going to call it demand management. So energy efficiency and other forms of demand management, such as demand response, et cetera, and demand flexibility can meet these needs. But we need to, again, turn from passive to active users. And then we can do that, you see on the bottom right, with water heaters, with appliances, et cetera. Next, please. And if we do those collectively, we can create something that we at U.S. Department of Energy have labeled Grid Interactive Efficient Buildings. It's not a very good name. It's not a very poetic name. But what we're communicating here is that buildings can be both. First of all, they have, well, three things. They have to be buildings first, and you can use their occupants. But they can be energy efficient. But they can also do it in a way that's grid interactive. And they can be a distributed resource that helps the grid balance its needs. And others will speak about solar and EVs and different ways we can look at the grid balance. But when we look at all the opportunities to use window shading that's dynamic, course, storage, and that storage can be either battery storage or thermal storage, which buildings are particularly well suited for their thermal loads, or connected lighting that can turn off lighting when rooms are empty, or even if they're lowly populated. We can now easily have controllable LED lighting that turns on task lighting where people are and turn it off where people aren't. And we can optimize that to look at all of the factors. Increasingly, one of those optimization factors is carbon dioxide emissions, and that varies enormously by market and jurisdiction, of course, but there's such attention globally to decarbonization. So we can look at cost, we can look at decarbonization, we can look at ambient air pollution, we can look at the reliability of the power grid. We need to balance buildings. I will say this, and I'm a buildings person, buildings are slow-moving beasts. They're not as easily able to, they don't change their functionality as quickly as perhaps electric vehicles do. But again, the quantity is so great in the US and most industrialized countries, they consume 3/4 of electric power. So by being able to shift them dynamically in a distributed fashion, it can make a big difference. And that, next slide, please. And that raises an important point for today's conversation. Distributed or decentralized energy resources often are quite small. The home I'm in right now, our peak demand is probably no more than 2 kilowatts. However, there's 119 million homes just in the US alone. So distributed resources need to be aggregated in a way that can make them utility scale. This is just a cheat sheet. These are just the 4 characteristics I've been describing that buildings can be to be grid interactive and efficient, connected to not only to the grid, but connected to the internet for remote applications, smart with microprocessors, and flexible. Next, please. And so if one of these grid interactive buildings is good, well, a lot of them is even better. So we can do communities. This represents a community, in fact, that EPRI was quite involved with, along with my office at the Department of Energy and U.S. utilities, looking at the ability to take distributed resources and to aggregate them. It gives us economies of scale, but also and greater impact on whatever the energy goal is, saving money, avoiding CO2 emissions, et cetera, but it also gives us greater flexibility because at any point in time, these, in this case, residential homes will have slightly different demand patterns, and if we can aggregate them, we can use the flexibility can be greater for the community than individuals. And communities don't have to be residential. They don't have to be big single-family homes like this photo shows. They can be apartment buildings, they can be commercial buildings, downtown areas, a whole variety, including existing buildings that can be retrofit to make them more flexible. Next, please. Now, as we do that, there's a complicated slide, but let me just focus on the X and Y axis. The X-axis is looking at energy efficiency. From the left, near the zero, is traditional or simple energy efficiency. Things like insulation or highly efficient windows that work well. They always work 24/7, 365 days of the year. That's the good news. But they're not as flexible. As we go to the right on the X-axis, we can be smart and or connected, and we can use energy management that's more sophisticated. However, if you look at this red line, as we get to the right on the X-axis, and that provides us more load flexibility on the Y-axis, it becomes more complex, and it's more important to have integration. So there is a complexity challenge, of course, to use sensors and controls that you don't have with insulation or double-glazed energy-efficient windows. And so it's important to deal with additional issues of connectivity, of cybersecurity, and privacy to do that. And I believe that's my last slide. And so the opportunities are very significant. We're doing a study right now at the Department of Energy with one of our national laboratories to quantify the size of this opportunity in the U.S. It's depending on different assumptions about cost effectiveness, but it's very significant, and it can lead to great carbon dioxide reductions. And the important thing with all decentralized resources to be able to aggregate them up. Thanks very much.
Thank you, David. That was a great presentation. And I already have some questions for you, but we have to wait till the end. So our next panelist comes to us from the EPRI family. His name is Haresh Kamath. He's based in Palo Alto, and he's a program manager for energy storage at EPRI. Now, he's a pro. He worked on spacecraft batteries at Lockheed, and now he's with us. And he's also a technology scout at EPRI's Technology Innovation Program. We can talk more about that during the Q&A. Haresh?
Thanks, Dipka. So thank you, everyone, for joining us today at this EPRI IEA conference. We're going to talk a little bit about electric energy storage technologies, especially how it relates to end use and distributed applications in line with what we're talking about today. So what you'll see is that a lot of what we're working with is very complementary to what David described. We often say that buildings and efficiency are probably the base for what we're trying to do in terms of energy use. And everything that we do with DER is really kind of lies on top of that. If you don't have a strong foundation, then everything else doesn't make sense. You have to eat your efficiency veggies before you can have your DER dessert. So that's certainly true for electric energy storage and for batteries. A lot of what we're doing is there to augment what we're already doing in buildings. But what we can do with energy storage is very special. If we want to get to 100% renewables, we're probably going to have energy storage in some form. If we want to achieve the level of resiliency that we expect from our grid in the future, then we're going to have to do that through energy storage. So a lot of that is based on technologies that we already have that we can implement right now. We don't have to wait for it. The question is really about value and benefits and understanding how that plays with the cost of those technologies right now and understanding that those costs are coming down very quickly. So next slide, please. So I'm sure a lot of people have heard about energy storage recently, and energy storage is not quite as straightforward as some of the other DERs that we hear about, like solar. It's not generating energy and putting it on the grid or supplying it to consumers. So what is it that's really driving energy storage? And it goes back to what we talked about, what I just talked about right now. It provides capacity, so it can provide resiliency, it can provide reliability, it can make sure that you have access to energy, even if your primary sources are not available. And it's also there as a, for basically a backup perspective. So this is being recognized in a variety of different ways through policy, and just from the standpoint of policymakers and how they are treating energy storage is very different than what it was 10 years ago. From an economic perspective, the cost of these technologies is coming down, and we have new ways through markets to compensate energy storage services. We're also seeing a lot more people care about the environment, and that means that people have to.
I'm not sure. Okay, you're right. We lost audio for a second, but now it's back.
Yeah, we just have to make sure that customer and that customers have access to these types of technologies. And then finally, we're seeing a lot of technological advancement that's just making these technologies possible. Next slide, please. So it's important to remember we do have quite a bit of energy storage out on the grid right now already. A lot of it, most of it is pumped hydro, and we forget about that huge resource that we have. Still, that enormous resource is still a very small percentage of the grid, typically about 2 or 3%. What we're looking for is a much larger percentage. What we've seen growth in the last 10 years is in battery technology, of which lithium-ion is the largest percentage. Lithium-ion is about 90% of the technology that's out there on the grid, and most of what has been installed in the last 10 years is lithium-ion batteries. And the main reason for that is, as I said, because the technology has improved so much. Next slide, please. So you probably heard about the cost coming down. The cost of lithium-ion has fallen substantially because of the amount of manufacturing that we have in place. This manufacturing was seeded by are vast, we have an appreciation for just how much the world has changed in the last 30 years because of consumer electronics. So there's a huge market for consumer electronics that really enabled lithium-ion battery to come to the fore. And now we're starting to see the same type of manufacturing happen for electric vehicles. And that has made the use of batteries much, much more inexpensive than they have been in the past. So this is just showing the way that we're expecting costs to fall into the future, but we've already seen an 80% decline in the last 10 years, and that has enabled a lot of new applications. Next slide, please. So what we're also seeing is that because the cost is falling and because we're having more, we have more familiarity with the technology, we can do a lot more with it. If you looked at batteries about 5 years ago, then you would see that we would have an average length of about 2 hours in terms of its duration. Today, we're seeing mostly 4-hour batteries out there. I know there are lots of folks out there who are looking for long duration storage technologies, and the conventional wisdom is that lithium-ion batteries are no good beyond about 4 hours. That's not actually true. We can use batteries for as long as we need to. We can make 6-hour lithium-ion, 8-hour lithium-ion. The question is whether it's cost effective. Today it's not, but it may very well be cost effective in the next 3 or 4 years. So this is something we'll continue to watch. That said, we are looking at other technologies, and there are other battery technologies and other storage technologies that we're investigating in the near term. Next slide, please. So some of those technologies, include, for example, sodium beta batteries, flow batteries. You probably heard a little bit about these technologies. Solid state lithium, way here on the left, is mostly in the research phase. And in between there, you can see hydrogen. A lot of folks are talking about hydrogen too, and hydrogen is a very interesting technology because it is potentially scalable. We can use it at very large scales, and we could use it at distributed scales. So there's potential for that technology as well in the near future. The one thing is that we have to remember is where's the investment coming from for these technologies? A lot of lithium-ion development was funded by consumer electronics and electric vehicle research and development. We will have to see where the investment comes from for hydrogen and other technologies to actually come to the fore. Next slide. So we have a vision for storage in the future. We realize that this technology is still nascent, and we would like to see a number of things happen in the next few years. So we put together this list of some of the things that the entire industry has to work on together to actually make this a technology that may actually become ubiquitous by 2025 or 2030. Safety, of course, is very important, and this is something that has gotten quite a bit of attention lately as we've seen some high-profile battery fires. This is not something that's insurmountable. We just have to address the challenges, and we've done that before. Electricity reliability, just making sure that we understand how energy storage fits into the grid. Economics, of course, the cost and the benefits of storage. Environmental responsibility, we don't want to create a problem while we're solving one. Disposal and end-of-life handling of batteries is very important. So this is something that we want to take a look at right now. And then finally, innovation. We want to understand how the technology evolves and not get stuck with technology that we're used to using in a certain way. So this is a really important aspect of what we're doing in the future. Next slide, please. So what we see in energy storage is the ability to provide flexibility, reliability, and resilience all the way across the electricity supply chain. We will see batteries connected at the transmission level. We will see batteries connected at the distribution level. We will see it connected at the grid, at the end use point. And maybe even some end-use devices will have storage embedded in them. There'll be storage everywhere, as long as it makes sense from an economic standpoint and a value standpoint. So these are, we think that this is really happening. We have the technology to do this, and it's just a matter of implementation, which will take a little while, but we're well on our way. Next slide, please. So I'll close by saying that really what we're looking at for energy storage is not to try to put this forward as a silver bullet. It is one piece of the portfolio. So what David talked about with buildings and the way that buildings can be used. Buildings can be used as storage too. And when we use batteries, that's very much a complementary approach to using buildings or using other technologies as well. In addition, we have to understand how all of these various types of technologies can be managed, and that's a very big part of our research right now. So thank you very much for your time. Appreciate it.
Thank you, Haresh. Excellent presentation. Now we'll hear from Sotiris Georgopoulos. He's the head of smart grid development for UK Power Networks. Sotiris is responsible for the business rollout of successful innovation projects. So this will be really interesting because you'll get a practical view what it looks like from someone on the ground. Sotiris?
To talk to the IEA and EPRI workshop. David went through lots of countries, but he didn't mention Greece. So a big shout out to any Greeks we have out there. I'm from Greece originally, but I've lived in London in England for the last 20 years. So I'll give you a perspective from how flexibility and the role of electric vehicles has developed in the UK market. Next slide, please. So just to understand where I'm coming from in my remarks. UK Power Networks that I work for is a distribution network operator. We are fully unbundled, and that's our sole activity. We have no interest in retail. We have no interest in generation. So our sole remit is to take electricity at 132,000 volts and distribute it to 8.3 million meters across the southeast of England. That's about 18 million customers. In terms of sizes, our winter peak is 16 gigawatts. And we have connected 9.5 gigawatts of distributed generation on the network. 6 gigawatts of those are renewables. Next slide, please. So one of the main developments we have seen in the UK over the last couple of years is the advent of flexibility, and distribution network companies like ours look into flexibility to make sure that we build the right size network and we built the lowest cost solution. So back in 2018, we published our flexibility roadmap. It's publicly available. You can have a look if you Google flexibility roadmap UK Power Networks. And we undertook a number of commitments. So first of all was what we call market testing, essentially introducing competition whereby all our new needs for additional capacity is put out to flexibility tenders twice a year to be competed across flexibility providers and then compared with the asset solution. So this is equivalent of or a version of non-wires alternatives, which over the last couple of years we've refined. And where we've got to currently is the level of participation for those tenders is 10 kilowatts. So we've taken the level of participation down to 10 kilowatts, which means a number of aggregated houses, as we said in the previous presentation. We also undertook commitments around neutrality, obviously to demonstrate that we are neutral when we make our selections. We publish a lot more information in terms of the size and the location, so there's a lot of visibility of where the system needs or the network needs are. There's a lot of information around our tender framework and the assessment criteria. And we are also publishing and using for the procurement of this flexibility a digital platform. The one we use is called Tiklo. It's an independent platform where we use to essentially make it as easy as possible to actually participate and bid in for those tenders. The other trend in the UK has been around collaboration. Obviously, we are all looking to develop these needs to benefit customers and keep costs as low as possible, but there's national collaboration in terms of the products and the flexibility products that are being offered by the distribution companies. So we have a national program here in the UK where it has defined 4 national active power products that we essentially, drive through standardization. And whichever platforms you are on, essentially you are buying or selling or trading the flexibility product. And the other trend has been around co-design of these arrangements. So we are not designing these flexibility markets or tenders in isolation. There's huge amount of input and close working with the actual participants and of course the regulator and government. And next slide, please. So these are, as I said, we are running to a year. These are the results of the one we ran last year. So last quarter. So we awarded in May this year. We awarded 123 megawatts of flexible capacity. The contracts vary from 1 year to 7 years. So that's feedback we had in terms of different business models. So there's flexibility in terms of the contract. And we awarded 103 megawatts of capacity, out of which 70 megawatts is actually batteries and EVs, and 30 megawatts is gas heating, gas generation. So the other new thing here is about the low voltage. So we awarded 1.5 megawatts of capacity that is mitigating constraints at the street level, at the low voltage network, and those constraints are constraints driven by electric vehicle uptake. Go to the next slide, please. Which takes me into the discussion about electric vehicles. Now, the electric vehicles and the role of electric vehicles in the UK, certainly at UK Power Networks, but I think it's a wider UK position from distribution companies, is that we are not looking at a direct control of electric vehicles or direct control of devices at home. Certainly at UK Power Networks, we believe the customer needs to have a choice of response. So we have, over the last couple of years, been exploring how we can really get EVs to solve the issue rather than be the issue. And we're looking at 3. So these are 3 trials, pilots that we have underway. The first one is around flexibility procurement, which I mentioned. It's actually the one that we've commercialized now and we use in our previous tender, where we identify the locations. We publish the windows of demand, and then we work with the companies, so the aggregators or the tech companies or the providers that win those contracts to essentially use them to dispatch and manage the issues before they occur. But we are looking at 2 other ways of managing the issue, which is not procure flexibility, and there are different types of charging. So the first one is a capacity-based charging, and we're working there with Octopus Energy, which is one of the suppliers or the retailers here in the UK. And we are looking at how we can define and at what level of granularity we can define capacity for retailers and profiles for retailers with penalties if they exceed those profiles as a means of incentivizing the behavior. And then they obviously have to manage their customer profiles to get within that envelope. And then the other work we are doing with OVO and Kaluza is about the distribution use of tariff that varies with the time of use varies with the electric vehicle constraint. I mean, this is not too different to what currently we do, where we have a peak demand window in our distribution charges, but move the peak demand window, if you like, from say 4 to 7 to 6 to 9, which is more representative of where EV issues might arise. So that's something that is fairly easy to implement, but of course not at the different tariff or dynamic tariff at this location, but a set tariff that reflects those constraints. Next, please. Thank you. So just those were some remarks to say that there's a big focus currently in the UK to introduce competition in the network space, and bring flexibility in to make sure we reduce costs and build the right size network. So we're very active in this space, and specifically with regards to EVs, which we see is the main, certainly for us in the southeast of England, is going to be the main residential low carbon technology that's going to drive disruption over the next 10 years because of the geography that we have. And we're looking at different ways really to work with third parties, intermediaries, and customers, and to create a market really to help us address those issues. Thank you.
Thank you, Satiris. Now we'll hear from Betty Watson. She's a Senior Director of Market and Policy Design for Modern Energy, which is a holding company for clean energy businesses. Now, Betty is a regular in the press. Before Modern, she was at Tesla. We'll come back to that press bit. Before Modern, she was at Tesla. Before that, she was at Solar City and an analyst at FERC. So she gets the regulatory requirements to renewable energy integration and the development of a new interactive grid. Betty?
Good morning, everyone. Morning here in Washington, D.C. Thanks so much for inviting me to speak here today with this amazing group. Right, as Deepka mentioned, I'm kind of coming with a previous view for regulatory experience, and really hoping to kind of add to what our great panelists have already said, kind of coming from the third-party provider perspective. Just moving on to the next slide quickly, as we already touched on, Modern Energy is a distributed energy company, and we have a number of clean energy businesses, from energy efficiency, participating in wholesale markets, to solar, to DER software, with more coming. So really working on kind of combining that range of DER resource, distributed energy resources to provide these grid services. So on to the next slide. I try to keep the slides to a minimum here, but we'll talk a lot. Now that we've heard about some of the great technologies that are becoming available in distributed energy resources, again, I want to talk a little bit about how businesses view using that DER. And again, on financing, there's no real secrets in financing, right? The goal here is to make revenue streams available and clear to customers, and if they're clear to customers, they can be clear to third parties. So just kind of starting from where we see the potential values, most assets on the grid, certainly in the U.S. and likely worldwide, have about a 55% utilization rate, which is not a particularly good business case. And this has actually been decreasing over the last few decades as cooling requirements tend to drive higher peak loads, but we've actually seen energy productivity increase, holding total usage stagnant or decreasing. So we see that relationship between peak and total usage continue to increase. Measuring that cost is really important. So the state of Massachusetts in the U.S. discovered, when it looked at this, that its top 10% of hours, the 10% of peak load hours, were driving 40% of its costs annually, $3 billion every year for a very small state in the U.S. Now, when we think about what that might look like for a customer signal, it's really interesting, because customers, especially for transmission and distribution, but frequently also for capacity energy, pay average rates. So in Massachusetts, when we look at the average value of capacity, transmission, and distribution to end-use customers, we get a rate of about $35 a megawatt hour. So not a particularly high charge for the customer. But when we look at the top 40 hours a year, and I picked the top 40 hours a year because those 40 peak hours drive the last 1,000 megawatts of necessary system capacity. So with 1,000 megawatts of system capacity built to serve just 40 hours a year, that cost is actually almost $8,000 a megawatt hour. That's a way different cost. And imagine if a customer saw, instead of a 4 cents per kilowatt hour average rate, if they saw a switch in certain hours to an $8 per kilowatt hour charge. That would change behavior wildly. That would also change the business opportunities to start to make the grid more efficient. Again, and this is a bit U.S. focused. I have these studies for the U.S. I'd love to see them from other places if people have them. New York calculated that flattening just the top 100 hours of its peak load would have long-term avoided costs for capacity and energy up to $1.7 billion annually. So we know that there's this incredible use case for using DER to start to shape load to the system that we have. We've historically built a system to a load that had to be served in every hour, but now with these additional technologies, we can actually kind of start to do the opposite. If from an economic point of view, we can have a demand side of the equation that starts to participate a little bit more. So we typically use DER to reduce customer reliance on the grid during peak hours it can be for system coincident peak to avoid capacity charges. It can be for a transmission peak or a time when the distribution line might be overloaded. Again, the key is kind of the signals and making the differentiated pricing available. So right now, the use case is really just saving customers money on their bills. It's going to be those types of customers that are the large industrial customers, small utilities that see these kind of coincident peak and monthly capacity charges. But again, there's the opportunity for customers to participate in programs or different rate structures that make those signals and revenue opportunities available to a much broader set of customers. One interesting thing that I want to clarify when I talk about this is a term that I saw in the poll earlier, and a term that I've seen in a couple of the presentations, is that it's really important when we're talking about the business case and the market case for distributed energy resources to differentiate between the market terms, supply and demand, which supply are resources that are selling services and demand are buyers of those services, and the physical location of the resources. And typically we've kind of conflated those. Suppliers that are resources selling services are also on the supply side of the grid, which has tended to mean front of meter. And demand has tended to be behind the meter, but that can actually be quite different now. And this becomes really important when we think about setting up markets and how distributed energy resources participate. So when we think about distributed energy resources as resources in the market, they're actually quite capable, and some resources need to participate on the supply side of the market, whereas some distributed energy resources and some customers will prefer to participate on the demand side of the market, simply reacting prices instead of making a financial commitment to a specific behavior in the market. Now, just kind of thinking about, okay, we know that we can start to kind of shape the way that energy demand on the system starts to look, and this becomes even more important when we start thinking about integrating intermittent renewables onto the system. So the graph in the middle is just a suggestion of how, in this case, battery storage could be used to charge during times when solar is exporting at a high level and discharge during times when solar is ramping down, but load continues to be high. Now, this also reduces that ramping requirement for the rest of the resources serving this solar net load on the system. So it's really important that we kind of take this ability to start shaping demand or end uses around the system and start moving that into a much more dynamic fashion in order to accommodate a high penetration of renewable energy on the system. It's also the case that smart inverters, storage technology, fast responding loads can provide additional ancillary services like primary frequency response, which was traditionally inertial response, but can be synthesized and doesn't need to be provided by a traditional rotating generator, frequency regulation, and reserve services. So we see DER as absolutely necessary to balance a carbon-free grid at least cost. And finally, for this slide, a really important piece of DER is that it's located at the customer site. and can function where there is no grid or where the existing grid is down. So we see island systems using solar and storage to function, to serve an entire grid exclusively. And we've also seen, certainly in the U.S., really great situations where storage being added to a solar system allows the storage to stay online when the grid is out, which wasn't previously possible because of some safety requirements. And that customers have been able to power their houses with those solar and storage systems for days during grid outages after hurricanes. So moving on to the next slide, the big question, right, is how do we get to all of those benefits? All of us have talked a lot about the potential benefits of DER, but there are still barriers. And for me, there's really three major steps, but I might add a fourth one that's not on this slide. And the first one, again, is about making the revenue streams available, allowing DER to stack all values. So distribution, capacity, energy, ancillary service, and resilience values is really important, but also making that peak pricing and time-differentiated pricing available when customers and third parties only see average rates for transmission and distribution capacity. There is simply no business model for reducing reliance on those resources or making the system more efficient. Again, it's really important to open all markets and planning processes to DER. So making markets technology neutral is incredibly important. And I'll also really harp on the requirement that it's necessary to allow all resources to participate comparably, which means accommodating the different attributes of different resources and not requiring them all to participate with exactly the same set of rules in the exact same way. And again, as we kind of talked about, I think I'll just wrap up, allowing DER to participate against all resource in planning processes as well. And I think the final statement I'll make is that we've seen a little bit in the comments, allowing access to data for third parties is the real key to unlocking the full capability of distributed energy resources here, and letting customers and all parties have the access to data around how the customers are using energy and how they can contribute to the grid. So thanks very much for the time. I'm excited to see everyone's questions.
Thank you, Betty. Excellent presentation. Well, we have a lot of questions coming in on the chat. I had some questions lined up for the panelists, but we do have a lot of questions. So let's just dive right in. I'm going to start with David Nemso from the Department of Energy. You recently joined Energy Secretary Dan Brouillette in Charlotte, where EPRI President Arshad Mansour and Katie Hareza toured him through a Meritage smart home. Now, at the event, Secretary Brouillette announced a $65 million funding opportunity for technologies to improve building efficiency and homes. My question is, do you have a sense of consumer preference? What sort of technologies are you really after here? We heard about a few today. There are a number of DERs. Can you talk a little bit about what exactly is DOE after, but what could actually come to bear pretty soon?
Sure. Thanks, Steve, for that. And I do want to say before I get into that, it is the Secretary of Energy did announce this competitive funding opportunity of $65 million U.S. I do want to say, because it's an international meeting, you do have to be American to be the lead applicant on that. But if you're non-U.S. and you're part of a team, that's fine. But the lead applicant has to be U.S. organization or utility or company or individual of some kind, because it is the taxpayers' money after all. And we're looking for demonstrations. Your question is a good one. What are consumers looking for here? I think it's dangerous. We're a country of 320 million people in the U.S., and if you think about all the countries represented on this call, You know, it's well over 1 billion people. So I'm loath to generalize on that. I think what you find is that different consumers, even just within residential, let alone commercial, have different needs and different priorities. Some of them are very concerned about climate change and are looking for energy efficient and clean renewable-based solutions. Others of them are more interested in the reliability of their power source, and others, many are just want the lowest lifetime cost, or even the lowest first cost. So it's really a mix. We're looking for any or all of the above. In fact, that's actually what we're most interested in this funding opportunity. We want to look at a portfolio of different projects. Some are going to be commercial, some will be residential, we hope, some will be new buildings, some will be existing, that look at different technologies and see how they perform. And, you know, Betty and Haresh talked about the integration of storage and demand side and renewables. We're interested in that. We're looking at the role of traditional in Meritage homes, the ones you talked about, Dee. There's a big emphasis on insulation with less on the smart stuff. So it's any or all. I don't mean to avoid the question, but it really is a demonstration project, a series of demonstration projects, and we're looking at all of it. But it has to be, my office is fundamentally about demand side management. We certainly care about electric vehicles and PV and renewables, but it really has to be on this particular project, have a big emphasis on demand side management and energy efficiency in particular. And if you go to our homepage, you can find that just where to apply and all the deadlines.
Thank you, David. Betty, let me jump to you. You talked about barriers. What are the and you have a history with FERC, you understand the regulatory environment. What are the key regulatory reforms or approaches needed to allow DERs to fully participate in utility and other markets?
It's a great question. There's obviously so much work to do. One really exciting thing that's happening is that in the U.S. is that the Federal Energy Regulatory Commission has recently issued a new set of rules for participation in wholesale energy markets by DER. So it's required that all wholesale energy markets, including capacity, energy, ancillary services, allow and accommodate distributed energy resources, and then created a set of minimum requirements that all the markets must comply with on how to further ensure that those resources are accommodated. So minimum sizes for aggregations, how to coordinate with distribution system operators, a variety of other requirements. And this is a really important step forward. Another really interesting thing to think about is, especially when we're talking about planning a system, DER don't look exactly like conventional resources that we're used to, conventional generators. And so a lot of regions have been doing work onto kind of how to value those resources in comparison with more conventional resources. So I like to think of it a little bit as kind of creating an exchange rate. So how do we do more of an apples to apples comparison? PJM, for example, has recently undergone a process to discuss how to use a method called effective load carrying capability to look at the capacity value of resources that may be able to operate for 24 hours or may be able to operate for 4 hours, including DER. And so really kind of thinking about how to make these markets and opportunities technology neutral, I think, is the first major step.
Thank you. Since you mentioned PJM, just a quick response, if you would. That proposal was fairly controversial, was it not? There were segments of the industry that didn't agree with it.
So the proposal for the effective load carrying capability, the ELCC, actually hasn't been filed with FERC yet. It was FERC required that PJM, which is the Mid-Atlantic market, the largest electricity market in the U.S., reconsider how it was evaluating energy storage, which was effectively to just require it to operate for 10 hours, which wasn't really aligning with the value on the system. And so stakeholders underwent a very difficult and very quick for a stakeholder process to kind of work together on how to create a program that would work for storage and renewables. And right, it was a very contentious process, but ultimately the package that PJM will be filing got 80% stakeholder support from the voters, which is an incredible consensus in PJM.
Thank you for that.
David, can I just add a quick comment?
Sure.
So not only was the grid built originally around centralized supply resources, but the regulatory system in the U.S. and the industrialized country was built around that same centralized investor-owned or publicly owned, but centralized regulatory system. And so just to state the obvious, that regulatory regime needs to change at the same time the grid is changing, because it was built to serve a different purpose that's no longer where things are at. So I just want to underscore the need for that.
Thank you for that. Yes, it probably needs to change from the ground up. Let me jump to Satiris very quickly. Really enjoyed your presentation, as did a lot of us. Since we're talking about structure, can you talk about the structure in the UK, a little bit about how did your structure allow for better renewable integration, some of your regulatory environment? I mean, because your business is a little bit different from anything we've seen in the United States.
Yeah, absolutely. So I think in the UK we have the generation, transmission, distribution, and retail. There is some integration amongst the different. So you do have companies that might have generation, distribution, and retail, but you have companies like ours that is standalone. In terms of the markets, our wholesale market, with a lot of the, I guess, bilateral trading is happening ahead of time, is a non-locational market. And then when you go closer to real time, we have a balancing market that and ancillary services run by our transmission company. To resolve, specific imbalances or specific locational constraints on the transmission network. And what we're seeing in the UK is this essentially evolutionary creation of flexibility markets at the distribution level. At the distribution level, in the integration of renewables and the interconnection piece is very much driven by availability of capacity. One of the key, I guess, more interesting aspects of the UK system is that expansion costs for renewables say 100 kilowatts and above are very much targeted back to the development of those renewables. So we haven't necessarily socialized the expansion of renewables, which, in a way that has happened in other countries, certainly Europe. So there is a very strong signal in terms of where to connect on the grid in the first instance. But what we are seeing in the regulatory framework, certainly for us for distribution, is that the framework that we have has been developed with demand in mind. Is a very similar comment, I think, to the comments before about, frameworks have been thought, with a centralized example. I think in case of the distribution network framework, regulatory framework has been very much has been developed with demand in mind. And although we have a TOTEX regime that doesn't distinguish between CAPEX and OPEX and allows us to use OPEX actions in the same way that we would use CAPEX actions, but that's only for the demand. On the generation side, which drives, if you like, integration of renewables, there's still a little bit of a discrepancy because, as I mentioned, a lot of the expansion costs are targeted back to renewables. So there is currently in the way a big reform that has been going on for the last couple of years and is due to give us a Minded2 position in the next month or so, that is looking at whether we need to think differently about how we're accessing on the network and the price signals associated with that, not just in terms of demand, but also in generation. So I think what we're seeing is that we're seeing a more unified framework moving forward. Certainly, that's going to come out of the regulatory reforms in the next few months.
Thank you, Sotiris. We have an interesting question coming out of the chat. David Hunter, am I allowed to say who asked the question?
Yep, if it's in the chat, you can.
Okay. This question comes to all the panelists from Southern Company, and you guys can decide amongst yourselves who wants to answer this first. What are two important ways for the long-term planning organization at an integrated utility where they have generation, transmission, distribution, to reflect or anticipate the role of distributed resources? Is that good? Is that clear? Does anyone want to take that?
This is Betty. I'll take a first stab at it. Thanks for the question. It is a great question. I guess my first kind of thought on how long-term planners can start to reflect and anticipate is, frankly, to be very proactive and involved. I think we've seen a lot of success in accounting for DER when we're actively utilizing it. So if we're talking about an integrated resource plan or transmission plan, actively assessing the opportunities for distributed energy resources to be a part of the solution, and choosing that solution when it does turn out to be the most efficient or most cost effective, and then kind of being a part of those programs is a really excellent way to start to see that reflected in the future plans.
Yeah, if I might just add, sorry, go ahead, David. Go ahead.
No, go
ahead. Okay, I know Southern asked for two, but our challenge is so big I have three. Betty covered one of them, so I agree completely, and that could be integrated resource planning or at least some other kind of planning that a big sophisticated company can do. Number two, you're a regulated company. Many of the companies are regulated by a commission. You need to work with your regulators, and we discussed that. If the regulators don't send the right signals or don't allow you to profit or have undue risk for you or your customers, you're naturally going to shy away from these solutions. So I think it's only fair that the regulatory regime give you every opportunity to make a good living off cost-effective distributed resources. And third, and this is especially true for a big company like Southern or EDF or, pick your favorite, to do demonstration projects. We're talking about a big swath of the globe here, and some are air conditioning dependent, some are commercial, a lot of commercial buildings, some are multifamilies, and the solution that there's a role for storage and for PV and all of those, but it's going to vary by all sorts of factors. So demonstration projects so that you can optimize for your service territory and your regulatory regime, I think, is something you can do. When it's a big company, you can take a little more risk than some other utilities or some other players are willing to do. So that's my list. I got about 10 more for you if you're looking. We can do that one offline.
Horace, did you say you wanted to respond to that?
Yeah, I think David said a lot of what I was going to say, but I'll just add one other thing is that as a business, your customers are your customers, and I think it's important to understand how they're using your energy, your product that you're giving them. I think that the expectations that customers will have for energy is evolving. They expect it now to be clean in addition to inexpensive and always there, always very highly reliable. So I think that as going forward, it's extremely important for utilities to understand what their customers are demanding in terms of the types of energy that they're going to get, where they want it from, whether they want some control over it, and how they're going to use it. And all of that really is going to roll into, into the planning that you do for your grid.
Well, our question for all of you as a follow-up is, are the customers really making this demand?
I guess I could start. I think that many customers already are. I mean, it's increasingly becoming an issue of certainly there have always been residential customers who say, well, I want to have solar on my roof. And so you as a utility have to accommodate it. And we've done things to allow for that. And I think that from a regulatory perspective and from other perspectives, I think that's desirable. But I think increasingly it's starting to become, that the penetration of those types of desires is becoming large enough that people have to really consider how we're going to do that in the best possible way. And from a business perspective, more and more corporations are saying they have net zero goals. They want net zero buildings, and they want to put their own generation on their roof to achieve that. And the question becomes, from a utility perspective, how do we enable that? How do we to satisfy that need from the customer? I think it's going to be increasingly important going forward.
Yeah, this is Betty. I'll add to that. Oh, go ahead, Soteris.
No, go ahead.
Thanks. Yeah, I was just going to say quickly, it's such a great point, and I think that customers are absolutely making that demand, and in a lot of ways, this is a very new demand, and customers are often unable to articulate it or unclear to what party they should make this demand. And we talk about this in markets a lot. This is a very new paradigm where we've gone from electricity being a commodity to electricity being a differentiated product with attributes that different people prefer. So it is really important for all of us, third parties, utilities, nonprofits, to start thinking about how to go to customers and actively solicit that preference, because I think it is fairly new for everyone to have customers have preferences about their electricity.
Yeah, I think that's a very good point, and build on that. In the previous question about what a utility would do to help really the DR market. One of the things we have seen is, and any engagement we've done in polling, it seems to be visibility of need seems to be an understanding of what the utility actually needs is the number one priority, with sufficient notice to mobilize, customer recruitment or, look at the business model, and then a joint up effort, obviously in an open, transparent way to understand how we productionize that. The part of the challenge is obviously, the DR providers are thinking about their market and, their economics and the way they think about the world, and the utilities think about their issues and their systems. And I think that, certainly where we've seen most of the benefit is where we, first of all, publish openly a lot of information about what we need, and then we engage into a process to translate that and see what it actually works for the DR market. And not just assume that, that market is the same market that has offered services to other existing, more centralized markets, certainly in the UK, because, those markets have been designed mostly for the bigger players. And whilst we are mostly interested to talk to, we of course want to talk to the bigger players, but we're very much interested in the smaller DR as well.
So I'd like to make a distinction. I agree with everything I heard, and again, I wouldn't want to generalize, David, and I'm so here, I wouldn't want to generalize about the billion consumers and users represented on this webinar, but I want to make a distinction and see if you agree with me between, I'm going to use Betty and Soteris as leading indicators. People are embracing in general, photovoltaics and electric vehicles at remarkable rates. And if anybody on this call said you predicted it 5 years ago, well, show me that in writing, because I think we've all been pleasantly surprised by that remarkable revolution. I'm going to submit that, no offense to you, Haresh, or to myself, that storage and buildings are lagging indicators, that consumers and end users are embracing PV and electric vehicles more quickly, and they're going to quickly but subsequently turn to storage and demand flexibility to help balance and help optimize the photovoltaics and the electric vehicles that they've already embraced. So I'm trying to give an all of the above answer, but I think there's a time element there. And I love buildings. Not everybody loves demand flexibility in buildings as much as I do. I get that. But as we have more and more decentralized, renewable, and other resources, I think we'll see more of it over time. And Haresh, maybe you don't agree, but with some exceptions, such as, fire-prone areas in California, I think people are embracing storage, again, as a result of the PV revolution.
David Nimso, I have a quick question for you since we are in the middle of a pandemic. Can you speak briefly about energy use during this pandemic and what this pandemic has really revealed about our consumption and et cetera?
Yeah, it's not good. So what it's revealed is that we have not seen, and IEA has data on this, the U.S. Has data on it, we have not seen the decrease in commercial sector energy and electricity consumption that I think we might have guessed if we knew we were going into a long-term pandemic. And I think that's quite unfortunate. We've seen the increase in residential as many people around the world work from home, but we haven't seen the decrease. So I think the takeaway there is still in this day and age, many buildings, especially commercial, don't have the kind of energy controls that can even look at a multi-month event, let alone a day-long event or an hour-long event. So I'm sorry to say, but I think it reveals that we're not close to where we should be. And I went into my office recently, and it had been vacant for months, and was 68 degrees Fahrenheit. I froze in there because there's no people to warm it up, and they're running the air conditioner at full. It's a rental building; it's not a government building. So it's disappointing, and obviously we need to do better in the pandemic. Hopefully we'll go away soon, but not quite yet, right?
And then a quick follow-up to that: do you ever see a time when the city skyline disappears? I mean, when we start becoming more efficient and stop keeping the lights on for no reason?
I'm a native New Yorker, so I have to say no on that one. But that may be just my prejudices.
That's fine. I'm going to jump really quickly to Haresh, and then we're going to do a quick lightning round. Haresh is, we're proud to say, he's a technology scout for EPRI's Technology Innovation Program. So, Haresh, and you look at power delivery applications and advanced energy storage technologies. Could you just briefly describe to this global audience how you analyze some of these technologies, and because I'm sure a lot of them come to you and they, these founders think that what they found is, the holy grail for DERs.
Yeah, it's a great question, Lisa. Thanks for asking that. I think, I think what we, look at, a lot of people, when they put forward a technology, they'll focus on a specific advantage or a specific difference according to what we have seen in the past. And I think we really have to look at these technologies from a holistic standpoint. How do they fit into the overall infrastructure of the grid? How do they actually relate to the customer, and how is it actually going to be used? So, for example, some things that are often just ignored in the way that these technologies are brought out is safety, reliability, what the cost is going to be when you take it out of the lab, and scale up of a product. A lot of times that scale up doesn't depend on the underlying technology at all. It really is about integration with everything else that we're using. And so when you test the technology in the lab, it's very different than using it in real life, at real life scale, in real life applications, in the way that people actually want to use it rather than under a controlled environment. So trying to understand those differences and how those things change is very important. Understanding that, unlike what you believe, taking technology to market is not a 6-month thing. It's not something where you just suddenly create something and then, it appears in the market 6 months later. It takes many, many years to do that, often, a decade to get there. And just as an example, lithium-ion batteries may not be the best example, but, they started in the lab in the mid-70s, and they didn't really commercialize the technology until the early 90s. And we're just now starting to see it in the grid 40 years later after it was first discovered. So not to say that all technologies take that long to mature, but it's not something that happens instantaneously, and we have to be cautious about it. And we have to remember that a lot of the investments that we make for research and development have to be long-term. We have to wait for it to mature.
Thank you, Haresh. Well, we have just a couple minutes left, so I want to jump into a lightning round of questions. Now, each of you has half a minute to a minute tops to tell us what you learned from someone else's presentation today, the takeaway. We'll start with David Nemso.
That's a great question. So, one, I relearned how multinational these issues are, and thanks to Tiras in particular for that. Two, I'd say in particular, I learned from Betty and thinking about the role of the federal regulators. The U.S., of course, is a federal system in which we have states and federal government, and I learned from Betty about the role of the feds in doing that.
Satiris, you're next.
So it was good to hear from Betty. I think the Betty's presentation sounded a lot like the DR perspective we hear in the UK, which is good, and kind of the real drive for change. And I think from David and Haresh, I think it confirmed the role of demand. And it was good from David actually to really hear about the role of grid responsive demand and the way of thinking about that, and from Haresh the role of storage as a technology.
Great, Betty.
Great. I learned a lot from everyone. I think from David, I really took away how much potential there is in buildings to reduce and shape our demand. From Haresh, I will always remember that as we're designing all of these programs, we need to make them technology neutral because something else is always going to be coming at us that we could utilize. And certainly from Satiris, I was really excited to learn that there are utilities and other business models who are really pushing the ball forward on utilizing DER.
Great. And Haresh, you're last but not least.
Yeah, thank you. A lot of what I was going to say has already been said. Three great presentations there in mind. But I think I really enjoyed Satiris' presentation and looking at how a lot of these issues are being handled in the UK. I think we really need to learn internationally about a lot of what we're doing here, and I think there's a lot that can be learned from each other through exchanges like this. I think what Betty's working on in the private sector is also very important. I think just looking at this from that perspective, from a market perspective, has always been critical, and I think it's something that we've really not done enough of. I think David's presentation is, of course, great. I think we always have to remember again that that efficiency is first, really, and that ultimately this all goes back to the customer. There's a lot of tendency these days to talk about the grid as if the customer is doing things for the grid, when really we have to consider that in the end the grid is there for the customer and has to be delivering energy to the customer. That always has to come first.
Thank you, Haresh. Well, we are out of time. This was a fantastic panel. And don't forget to follow us on Twitter at EPRI News. We'll be posting some things throughout the day. Back to you, David. Hunter, that is, David Hunter.
Oh, let's see. Okay. Thank you very much, Dee. I haven't figured out how to do a virtual round of applause for all of our panelists, but imagine yourself all having a huge, tremendous virtual round of applause for a great panel today. Let's see. We did do a poll this morning. Let's see. Fiona Baker, can you pull up the poll results? We're actually out of time, but if you could just go through them very, very quickly. Looks like we had a little bit, 110 or so people responding to that poll and got some interesting results. So Fiona, if you're there and can pull those up.
I am here, and you should be able to see my screen now. All right, wrapping up with what we heard from all of you in the poll this morning. The first question was, in the future, how will the role of centralized resources change relative to distributed energy resources? And overwhelmingly, the response was DERs will grow in importance, but centralized resources will still play a critical role. I do wonder how this response would change if we had put a specific year range, whether it's 3 to 5 years or beyond that. But largely expecting DERs to grow while still having a role for centralized resources. Moving on to question 2, we asked what will the main contribution of DERs in a decarbonized world? Largely, we had providing demand-side flexibility. There are a number of folks who answered providing low-carbon energy. I will also flag that in the others, we had 5 different people mention all of the above, and I do think that we should have included that as one of our response options. I think maybe a couple of people would have chosen that one, and that may have actually been our top priority. Moving on to question 3, which of the following DERs will make the greatest impact towards decarbonization over the next 5 years? Here we see distributed PV as our front runner, followed by distributed energy resources. We did have a couple of other responses of all of the above or a combination of some of these different options as well. And then really quickly moving on to question number 4, which is the most important to advance so that DERs as a whole can have the greatest impact towards decarbonization over the next 5 years. You see far and away the regulatory treatment of DERs, including price signals, with 52% of folks responding with that option. And again, all of the above probably should have been an answer choice here as well, as we did get a couple others that expressed that option.
Great. Well, thank you so much, Fiona. Just a quick reminder to everyone that we do have a great panel lined up for you tomorrow, exact same time, whatever time zone that may be for you. Actually, tomorrow or the next day, but tomorrow's panel is Government and Regulatory Perspectives. And we've got a great set of folks from government folks from Norway, from California, from New York, from NTOE, FERC, the Energy Networks Association. So I do very much encourage you all to join in tomorrow. This concludes our webcast. Actually, we will be leaving the line open for a few more minutes, and we will be leaving the chat open. So if anybody has comments that they want to offer in the next couple of minutes, either feedback on today's workshop or suggestions for future events, or continuing to ask questions of the speakers. And if the speakers can stay on for a couple of minutes and see if there are any other questions, that would be great. Otherwise, if you can't, we'll get those questions to you and see if we can address them for one of the next ones. So again, thank you very much, everyone, for joining. And we will now officially sign off, at least on the verbal point, but again, keep the call open for a few minutes for the chat. Thank you very much.